Hello everyone, I'm Ajaz Shaik. Today I'll be talking about impact of obesity and physical inactivity on diabetes. Along with me I have Farid Chamadiya as well as Shivani Pogul who will be joining me in the later part of this presentation. This project is an academic project under Business Intelligence and Tools and Techniques at Oklahoma State University. This project was performed under the guidance of Dr. Brian Hammer. Okay, coming to agenda, today I'll talk about a brief introduction about the project and what is the background, what is the plan and how did you execute it, what are the steps which you took to prepare the data and what are the different kinds of descriptive statistics which we have done. We also discuss about the regression models, different kinds of analysis models which we have built. We'll also try to assess those models and we'll also discuss about the time series analysis which I have done for the data. There are also some recommendations which I have done. Apart from that, there are some original goal versus final output comparison which we have done, as well as we'll also be discussing about the lessons what you have learned doing this project. Okay, we all know that diabetes mellitus has been one of the most bothersome diseases for international and state health agencies across United States. Now, this is because there are more number of people getting diagnosed every year with diabetes. It has now become so serious that it causes more deaths than breast cancer and AIDS combined together. Now, we know that there are a lot of reasons why diabetes can occur. We have chosen two important reasons why diabetes can occur, which is obesity as well as physical inactivity. We also try to quantify the relationship by building some regression models and various other models. It also aims to identify the relationship geographically. We have done some year-wise state and county level analysis, which we'll see going forward. Now, the plan of the project is to perform an exploratory analysis of the percentage of people diagnosed with diabetes at a state and county level. We're also doing a year-wise analysis of diabetes and each of the factors which I've considered. We also combined some demographic data from census, like income and poverty level at the particular county. Now, we also tried to build some models to understand the relationship between the target and the predictor variables. Later on, we'll also do a time series analysis in order to forecast what's the number of people who will be diagnosed with diabetes in the coming future. Now, what are the benefits? I think these results can be really helpful for local health centers to understand what are the particular areas where they should concentrate for awareness. It will also help pharmaceutical companies to gauge the amount of drugs people will need. Now, we all know that International Diabetes Foundation invests around 15 million pounds towards their projects on diabetes awareness itself. So this would help them streamline where to focus, which areas are most affected with diabetes and obesity. Now, implementing geographical analysis would also help us identify the lifestyles and demographics of the people who are diagnosed with obesity and diabetes. We have started this project earlier in January, and then we have continuously worked iterative wise, and then we have ended the project successfully by 30th of April 2014. Now, constraints. Performing this project, analyzing data, we found a lot of constraints. We have mentioned a couple of them on the slide, we had limited number of variables to predict diabetes as a target variable. So this is one of the constraints which we had. Apart from that, there is very little data which we could accumulate, which was only from 2004 to 2010. So we tried using this data and tried to give a forecasting results till 2016, but this results might not be accurate. Now, data preparation. This is the most important phase of any business intelligence project. We created data from two different websites. One is from Center of Diabetes and also from Census. So these are the links which we have used to download the data. Now, we also consolidated these data using SAS Enterprise Guide. We used a lot of SQL queries as well as SQL Query Builder in SAS. We also done some data cleansing where we had to do a lot of missing value imputation for various variables. We had to do data transformation for the skewed variables. We had to do data reduction in terms of reducing the number of variables which are present in the census data as well as in the main master data set. We also ended up with this final data dictionary where we can see what are the variables which are used to create this or make this analysis. Now, coming to descriptive statistics, we use SAS Enterprise Guide as well as Tableau to understand data much clearly and much in a layman's picture. When we see that the means, the average number of people getting affected with diabetes in each county across the United States is 9.5%, which is a pretty high number for a country like United States. Let us see the distribution of diabetes percent, which is present in our data. Now, this is from 2004 to 2010. We see that the data is pretty normally distributed. Coming to distribution of obesity, this is also normally distributed, and this is a scatter plot between obesity and diabetes percent, which gives us a relationship between diabetes and obesity percent. Now we can see that there is a positive relationship where when we can see when diabetes percent is increasing, obesity is also increasing. Same is the case with physical inactivity. This is also a normally distributed data, and then this is also having a positive relationship. Now coming to obesity and physical inactivity, even these two looks like they do have some kind of positive relationship. Coming to distribution of median household income, this looks pretty right skewed data, but then there was very less skewness in kurtosis variation which we saw, so we thought we'd continue with the same distribution of the data. And then now this is the plot between diabetes and median household income. We see that this is a pretty widely spread graph now, but the interesting part is at the bottom of this graph, where we can see that the people with where we can see that the people with low income are affected with diabetes. So we'll see what is the reason why is this happening in this when going forward in this presentation. Now this is a distribution of poverty estimate, but this looks little right skewed data. So what we thought we'll do a log transformation and then bring the skewness in kurtosis value to the normal level. So this is what transformed distribution looks like. This is the scatter plot between poverty estimate as well as diabetes percent. We clearly cannot make out something within this plot, so let's see. To understand this better, we have built some regression models which we'll see in the coming slides. Now this is a state and year-wise analysis using Tableau. We see that Mississippi has got highest percentage of people who are diagnosed with diabetes, as well as when you see at the minimum, we see that the Colorado has got the minimum amount of people who got diagnosed with diabetes at the county level. Now this is obesity percentage distribution across the United States, which is given state-wise. Again, Mississippi is leading in this statistic, and then Colorado has got the minimum amount. Now going forward, this is leisure time physical inactivity. This is little different than the other two. We see that Kentucky has been leading this statistic, and then coming to Colorado is again the minimum LTPI percentage. Now this is year-wise analysis of diabetes in all counties across the United States. Now we see a pattern where when we grow from 2004 to 2010, there is an increase in number of people who got diagnosed with diabetes at a county level. So this is really important to understand that there is no decrease in the trend. There should be some serious steps taken by the government. Forward, we'll discuss about how did we relate these variables more accurately with the target variable, which is diabetes, by building some regression models. This part will be continued by Chamadiya. Thank you.
Thank you very much, Ajaz. Hello everybody, my name is Chamadiya, and let us now move on to the crux of our project, which is building models for analysis. We've seen how our variables, which is the diabetes percentage, the obesity percentage, and the leisure time physical inactivity percentage, vary both state-wise, county-wise, in the US and year-wise. Let us try now linking them, relating them by building models. In this project, we built 4 models, which is a regression model, a neural network, a chi-tree, and the CNR tree model. Let us now start understanding how the neural network was actually built. Before building the model, we actually split the data into 3 categories, which is training data, validation data, and testing data. And the percentages are given there. We put 60, 20, 20 for training, validation, and testing data respectively. The target variable is obviously diabetic percentage, as that is one thing which we would like to predict in the future for different counties. The input variables are obesity number, leisure time physical inactivity, median household income, and poverty estimate. Coming on to the results of neural networks, we've given predictor importance graph for all the variables, and from the year 2004 till the year 2009, we see that there's a clear winner. LTPI percent is winner by a very large margin, as we can see in the graph. What this tells us that the most important variable in this model for prediction of diabetes percentage is the LTPI percentage. And what we can also infer from this is that LTPI percentage is very closely related to the diabetes percentage. Okay. Here's a sample neural network what we've built for the year 2010. Uh, as I said, this is our dependent variable, and this are our independent variable, and these are basically the neurons wherein the neural network is actually built by a biological emulation of neurons, and it understands the pattern of the data, and it makes a hidden layer of neurons, and what exactly happens in those neurons is pretty much inexplicable. All we get is a relationship between input and the output. As far as the model accuracy is concerned, the table shows us that it is the most accurate in the year 2006, which is 62%. Coming on to chi-tree now, chi-tree is actually a type of decision tree which works on a special algorithm known as chi-square automatic integrator detector tree. Again, we've split data here in training, testing, and validation. The input and output variables remain the same, and we've done this in IBM SPSS again. Okay, here's how the decision tree actually looks. This is known as the root node, and these are known as the leaf nodes. Based on the values of the independent variables, rules are written, and based on those values, we arrive at a final leaf node. Uh, on the right hand side, as we can see, we've tried to mention the accuracy, and we've measured it year wise. We see that accuracy pretty much remains the same in the high 70s, which is pretty good. And again, by this model, chi-tree also predicts that the most important predictor variable here is LTPI percentage. Coming on to the CNR tree model, this model basically works on the principle of classification and regression. What additional result we have here in CNR tree model is the R square value for each model. The R square value is actually the percentage of variance explained by the input variable for the output variable. Okay, here are the R square values for the year for the models built for the year 2004 to 2010. We see values ranging from 76 to 79 percentage, which is 0.76 to 0.7, which indeed is pretty good. I mean, having an R square value more than 60 to 70% is very good. That means that, for example, say year 2006, the value is 0.799, which states that 79% of variation is being captured uh, uh, by the input variable of the output variable. I mean, it's like 79% of the variation in the output variable has been captured by the input variable. Okay, now let's come on to the regression model. This is something which is personally my favorite. The reason why this is my favorite is because of the fact that it is pretty simple to explain and very easy to understand. All regression model does is gives us the linear equation of the input and the output variables, and it gives us an equation in the form of y is equal to m0 plus m1 x1 plus m2 x2 plus m3 x3, and m0, m1, m2 being the regression coefficients or the regression betas, and x1, x2, x3 being our input variables, and y being our output variables. For building this, we've used the stepwise selection method. Let us try and interpret one of the model results for the year 2004. Let us try and interpret what exactly these numbers mean. Say what we see here: 0.23, 0.9921, 0.09, and the minus 2.7 10 to the power of minus 5. These are regression coefficients. These are regression coefficients for the input variables. And what exactly do they mean is the fact that if we keep all the variables constant, and if we increase the value of obesity percentage by 1 unit, the value of the diabetes percentage increases by 0.23 units, and this is how regression coefficients are understood. And on the right hand side, these are the standardized regression coefficients. Coming on to the next slide. I've explained standardized regression coefficients here in this slide because comparing coefficients for all the variables isn't logical unless they are standardized. I mean, we have different scales for different variables, so unless and until we standardize the regression coefficients for all the variables, there's no sense in comparing them. And this is done in standardized coefficients, and these are the standardized coefficients for all the variables from the year 2004 to 2010. Let us try and understand this graphically. And in the graph, by a clear margin, we see obesity percentage and leisure time physical inactivity percentage contribute to the major part of variation, as to their betas or their regression coefficients are pretty high, which means that they are more important as far as prediction of our output variable is concerned.
We now are at the model assessment section, and I would like to call Shivani to take it forward from here. Thank you.
Thanks, Farid. The next step after model building in CRISP-DM is the assessment of models. As Farid mentioned, we have used 4 models for each year starting from 2004 to 2010. The criteria used for assessing the models are model accuracy, model performance evaluation chart, predictor importance, and number of fields. Coming to model accuracy, it is a measure of how well the model is performing on the validation data. As the target is continuous, we have used average square error as the assessment criteria. Now, as you can see, the regression model is the best model for the year 2004 because it has the lowest average square error and highest accuracy of 81%, followed by classification and regression tree, which has a 76% accuracy. Same is the case for 2005, 2006, 2007, 2008, 2009 and 2010. Coming to the next criteria, performance evaluation chart. We have considered 40% population depth, by which I mean if we take the top 40% of the population, how much is the gain for that particular model. Here we can see that the regression model has a gain of 9.4 on the validation data. The next criteria is predictor importance. Most of them do not take into consideration predictor importance because they do not think it is. The next is the predictor importance. Most of them do not take into consideration the predictors used by the model to assess it. For example, if we are building a model to predict whether a person will take an insurance or not, and if the model selects his favorite holiday spot as the input, that doesn't make any sense. The regression model has selected the following variables: obesity percentage, LPTI percentage, poverty estimate, and median household income. All the 4 are the important variables. Assessment results based on accuracy, evaluation charts, predictor importance, and regression model is considered the best model. Other than the above results, regression model is chosen because it has the best combination of input variables which could explain the target variable. It can be easily explained to managers who do not understand predictive modeling. The regression coefficients can be easily interpreted. Based on all these factors, we have chosen the regression model as the best model to predict. The next interesting aspect of the project is the time series analysis. Someone rightly said that time series data mining is a marriage of forecasting and traditional data mining techniques that uses time dimensions and predictive analytics to make better decisions. We have used SAS Enterprise Miner to perform time series analysis. Exponential smoothing method was used to forecast the number of diabetic people in the future. We have chosen diabetes count as a target variable, and the input variables are estimate of poverty percentage, mean household income, obesity number, and leisure time inactivity percentage. As you can see in the figure, from the year 2011 to 2016, there is a drastic increase in the number of people who are affected by diabetes. It is shown that approximately there are 13 million people who are affected by diabetes. Recommendations. It is found that in Mississippi, there is a highest number of population who are diagnosed by diabetes. Hence, it is a soft location for pharmaceutical companies to improve their business. Next is Kentucky and Colorado, which has the highest number of obesity and leisure time inactivity. It is helpful for local health centers to spread awareness and fitness equipment manufacturers to target specific locations for marketing. Time series analysis have given an alarming results, and it has shown that approximately there is a 26% increase by the year 2016. Hence, this data will be helpful for United States Department of Health and Human Services, who will take necessary actions and spread awareness among the people about health. Original versus final. In the original objectives, we wanted to find whether there is a relationship between diabetes, obesity, and physical time inactivity, and we wanted to find the states which are most affected by diabetes because of obesity. We plan to analyze the effect of demographics on diabetes and obesity patients. In the final version, we have performed exploratory analysis to find the relationship between demographic data and target, identify the states that are most affected by diabetes, build models to identify the magnitude of effects of predictors on target. In the original plan, we plan to forecast the future diabetes numbers. In the final version, we built a time series model to predict the value of target from the year 2011 to 2016. Lessons learned. This project is most valuable experience in terms of how to do a project. The most important lesson we learned from this project is to get to an excellent result, we need to perform iteration. That is, we need to iterate through all the phases of the project to get best results. On the beginning of the project, we did not realize that the data preparation phase would take 70% of our time. At the later stages, we realized that it takes only 30% of the time on data analysis and model building. It is very important to set multiple objectives rather than focusing on a single objective, because at the end of the project, we may not be able to achieve that objective. Best models are built only through refinement. It is only through changing input variables and trying out new models we can get to the best model. Lastly, I would like to thank Dr. Hammer for guiding us throughout the project. Thank you.